Hello and welcome. Today we're going to be looking at right triangle word problems, which is a topic on the additional topics in math section, which is the last section on the SAT math portion. As always, we're going to be looking at 5 different questions. We're going to explain them, and then we're going to look at the intricacies in this topic so that you can ace the SAT math section. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Here it is. A plumber slopes a drain pipe 3/4 of an inch diagonally downward for 12 inches of horizontal distance. The pipe extends 528 inches horizontally. To the nearest inch, what is the length of the pipe? Let's see. So essentially, it slopes 3/4 of an inch down for every 12 inches outward. And the length of the pipe is this much. So we see a right triangle here, which we probably should have expected, given that this is a right triangle word problems after all. But we have 3/4 of an inch here. We have 12 inches here. So in the 528 inches, we have 44 groups of 12 inches. So 528 divided by 12 is 44 times 3/4. So we're going to have 33 inches, and then 520 or 33 inches and then 528 inches. Not to scale, obviously. 33 versus 528. And we need to figure out the length of the pipe to the nearest inch. So we're going to use the Pythagorean Theorem. 528 squared plus 33 squared, and then we take the square root of that, and we get 529, which really we should have suspected, since 533 is so much less than 20. Since 533 is so much less than 528, this is going to be around 528. 529 is our answer, and we can move on to the next question. All right, here we are, and here's the question. A plane flies approximately 30 degrees north of east for 12 kilometers and continues the next 31 kilometers is 60 degrees north of east, as shown at left. What distance is in kilometers between the location? Well, it travels 12 kilometers here and 31 kilometers here. Now, how are we going to figure out what this is? Well, if you know your trigonometric functions, you know that the side length here is just going to be 12 cos 30, 12 cosine of 30. And even if you don't know those trigonometric functions, you don't have to worry about that, since this is a special 30, 60, 90 triangle, where 30, 60, 90 triangles are like this. So this is going to be the 30 degrees, and this is the right angle, and this is the 60 degree. And we have, say, x right here. That side length is x. The one opposite the 60-degree angle is going to be x root 3, and the one opposite the 90-degree angle is going to be 2x. So since this 12 is going to be 2x, so x is going to be 6. So then x here is going to be opposite 30 degrees, and that's going to be 6. And down here, this is just going to be 6 times the square root of 3. You can do the same thing on this one, knowing that this is 30 degrees, and that this is 30 degrees, and that 31 is the 2x, so x equals 15.5. This is 15.5. This is 15.5 root 3. So we're going to we have 6 times the square root of 3 plus the 15.5, which is going to be 25.9. And on the other side, we have the 6 plus the 15.5 square root of 3, which is going to be 32.8. We put that in the Pythagorean theorem. And we get that this is going to be 41.8 kilometers. That is just 42. And we the next question. keep going. All right, next question. Here we are. A ladder is leaning against a wall. The top of the ladder is 9 feet above the ground. If the bottom of the ladder is 3 feet farther down the wall, the ladder will be lying flat on the ground, still touching the wall. So if we move it 3 feet down, the ladder is on the ground, lying flat. So that means that the height is, let's just draw it actually before we start thinking of what's going on. So 9, and this is going to be x, say, actually we can make this x, and we can say that this is the square root of x squared minus 81 by the Pythagorean theorem. And if we increase this by 3, we make this 3 more by moving it 3 feet farther from the wall, then this part becomes 0, which means that the b plus our x squared of x squared plus 81 is going to minus 81 is going to be our length of the ladder. So we get x minus 3 equals to x squared minus 81, and we square both sides. You should remember that if you watch the other videos, you should remember that this is similar to what we did in the radical equations. If you haven't, I recommend go checking out that video. We're going to end up with something that looks like this. The x squares are going to cancel, and then you add 6x to both sides, you add 90 to both sides, and you're left with 6x equals 90, and x equals 15. So the ladder is 15 feet long since x is the length of the ladder. Our answer is 15. And if you do see this here, you'll notice that this is a 9, 12, 15 triangle, right? That is the length of the sides. This is a derivative, kind of, not like a derivative as in calculus derivative. This is just like a derivative as in you derive it from the 3, the 3, 4, 5 triangle. If you multiply each of these by 3, you get 9, 12, 15, which is what we just got here. We got 15, and we can move on to the next question. All right, here it is. A street on a hill slopes upward evenly, such that the street rises 1 foot vertically for every 4 feet traveled horizontally. So something looks something like this. 4 and 1, this is going to be the square root of 17. The bottom of the street is 60 feet lower than the top of the street. So this is going to end up being 60. So then this part is going to end up being 60 times the square root of 17. 60 times the square root of 17 is going to be the length of the street, which is answer choice C. So that's our answer. Let's keep going. All right. Next question, here it is. A spiral staircase makes 4 full turns as it climbs 20 feet, represented in the figure at the left. But the length of the spiral can be represented by the hypotenuse of a right triangle by unrolling the spiral to a 2-dimensional shape. The outer railing is a constant distance of 2 feet from the midline of the staircase. About what is the length in feet of the railing? All right. So essentially, let's see what we can do. Let's see what we can do here. All right, let's think. So we're making 4 full turns. So if we make 4 full turns, then each of these is going to be 5 feet, right? 5 feet. And the length of the spiral of the railing is going to be the hypotenuse of this triangle, which is basically has legs of 2 and 5. By the Pythagorean theorem, this length here is going to be the square root of 29. And this is for each of the 4 turns. This is going to be 4 times the square root of 29 for the whole thing. 4 times the square root of 29 is going to be 21.5. So that didn't work. Let's try again. And let's think about what we did wrong and where we can change that, right? If your answer ever doesn't fit, or if it doesn't seem plausible, if it's like a written response question, be sure to check it. Be sure to check it anyway. It's just good practice. All right. So let's think again about what we can do. The outer railing is a constant distance of to each line of the staircase, and it makes 4 full turns. Well, let's think about what that means. 4 full turns, that's 4 circles. It's really just making like a circle, 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 circle. The 4 circles, well, each of those circles is going to have a radius of 2. So each of those circles, circumference is going to be 4 pi. So the total is going to be 16 pi, or around 16 pi, which is 15.2. So that's the length, right? That's the horizontal length. Well, the height is still our 20. So we use the Pythagorean theorem on 50 and 20. We take the square root of that number that we get there, and we get our answer 54. So our answer is choice, and we're done. We are done. All right. So that was this question on right triangle word problems. As you can see, it has the same basic structure. You find the length of the legs or the hypotenuse. Use the Pythagorean theorem to find everything else. And in that one question we saw, we can use these special triangles, which are the 30, 60, 90, where you have 2x, and then x for the 30 side, and then x for 3 for the 60-degree side. And then we also have another special triangle, which is 45-degree triangle, where 45-degree triangle, where they're both 45 degrees here, and this is 90, and we get x, x, and x root 2. If you can remember those two special